Okay, so go ahead and crank this out. I'm going to go ahead and when you pause it, do the problem, come back. I'll have the answer on here for you, and then I'll go ahead and go through the work. The answer is actually going to reduce to cosine. It says right in terms of cosine. It actually does reduce to that. So what I'm going to do here is the tangent squared. There's a Pythagorean identity for that, but I'm not going to use it because the top is, I see some stuff with the top that might be worth working with. I know that's redundant, but secant equal to 1 over cosine of theta. And this would be cosine of theta over 1 all over tangent squared theta. So now I'm just going to focus on the numerator. And I know I'm actually going to change tangent. And I'm going to change tangent to sine squared theta over cosine squared theta. Okay. And so what I'm going to do here is, if I get a fraction, one term over another term, you multiply by the reciprocal. So I'm going to work with the numerator, and I'm going to get a common denominator and combine these guys. So in order to do that, I need to multiply. Now this guy already has 1 over cosine. So what I need to do is I need to take this guy right here, and multiply it by cosine over cosine. So I'd leave this here, minus cosine of theta over 1, and I'd have cosine of theta over cosine of theta. And then I'll just continue with the bottom and bring it along. And now this, right there, this didn't change, is going to be cosine squared theta all divided by cosine. And now they have a common denominator, and I can combine them and make one term. And hopefully what you're seeing here is when we get these guys together, it's one of those Pythagorean identities. Okay, so I'm going to go ahead and I'm going to continue all the way down here. And I'm going to write it as one term. I'm doing step by step here. When we add or subtract fractions, the denominator just stays the same, right? As long as it's common between both. Oh, this 1 minus sine cosine squared. I have this identity, sine squared plus cosine squared theta is equal to 1. I can move the cosine over, and sine squared theta is equal to 1 minus cosine squared theta. So now I can replace this whole thing with that. So that means I got sine squared theta all over cosine of theta, all divided by sine squared theta divided by cosine squared theta. How do we divide fractions? We multiply by the reciprocal. Okay, so this is a fairly lengthy problem. Okay, we're already at almost 4 minutes here. But you could see that the sine squareds cancel out, and I got a square here and a single one there, and we're left with our cosine of theta problem. Okay, so go ahead, pause the video, try and simplify this, and from here, once you press the play button, I'll have the solution up there. Okay, so the solution is secant of theta. So how did we get that? This one might be a little bit less involved than the other one, but it's got the same idea. First thing I'm going to do is I'm going to take cosine of theta plus sine of theta, and I'm going to take tangent, and I'm going to rewrite it in terms of sine and cosine. And I'm going to combine the left side, because it's multiplication. We've got to do that first. Okay. Well, this guy's over 1. This guy's over cosine. So 1 cosine. So what do I need to do here? I need to get a common denominator. So I'm going to multiply both by cosine of theta. This one doesn't look very well. Hopefully the penmanship is not too bad. Clean it up a little bit. And hey, all right, I got a common denominator now. Cosine times cosine is cosine squared theta all over cosine of theta plus sine squared of theta. I didn't change this one on the right. And now I can write this all as one term. And the denominator stays the same. And hopefully you're saying to yourself, oh, cosine squared times sine squared plus sine squared, that's equal to 1. 1 over cosine of theta, which is equal to secant. And there we go. So those are 2 examples. We'll have 2 more, and this will end the identities, and we'll move on to something outside of this. Now, the identities are good practice. It is going to be important in your next year's classes, and if you go on to calculus, you'll work with it quite a bit, or a decent amount, I should say. But this is definitely, you got to practice this stuff.